Hello, so in this video I'm going to review the 6 steps of a derivation with reference now to indirect derivation, and then I'll do a couple of indirect derivation examples. So, first step is the same, show the conclusion. Second step is different. You now always want to make an assumption. If you can, do assume CD. If you're trying to show a conditional, assume CD. That hasn't changed. But you can now do assume ID in any other case. Assume ID lets you assume the negation of the conclusion, and the conclusion always does have a negation. If the premises are true, the negation of the conclusion is false, but the sentence exists. And so you can always make an indirect assumption, and that means you can always make an assumption. Conditional if you're trying to show a conditional, negation if you're trying to do an indirect otherwise. Now, that means you could have done an indirect assumption in all of the previous derivations we've done. It wasn't necessary in any of them, obviously, and so, because you didn't do them, but, and that means that going forward, you're always going to be in a situation where you could make an indirect assumption, and it might not be necessary. And making it could make your derivation a little bit longer. It's going to add a line, and it might make it a little bit more confusing. You have more to work with. On the other hand, you might need the indirect assumption. So I would go ahead and make it automatically now, knowing that I may not need this. But again, remember, if you can, you prefer to make the assume CD. You only do assume ID if you can't. And then we proceed as usual. So we enter our premises. We apply our inference rules, knowing that we prefer elimination rules. If we get stuck, if the derivation gets stuck, we do a subderivation. And when we do a subderivation, we might do assume ID as an assumption there. And then we box and cancel. But now we need to remember there are more options for boxing and canceling. We have DD, which is the conclusion, CD, which is the consequent of the conclusion, or ID, which is any contradiction. And that you have to pay attention for. You have to look for those ID opportunities, those contradictions. Previously, when you look at the show line, you know, okay, I'm going to get the show line, the conclusion, or I'm going to get either the show line or its consequent because it's a conditional. Now you know, I don't know, any contradiction might do, and you don't know what the contradiction is going to involve, so you have to keep your eyes open and be looking for that contradiction. Okay, so let's take a look at some examples with indirect derivation. Okay, so here we have an argument, not P, not Q, therefore not P or Q. And this is certainly valid. For P or Q to be true, at least one of P or Q has to be true, but neither of them are true, and so the disjunction should be false. So we'd say show conclusion. Now if we just had premise 1 and premise 2, well, we could do addition, and you know, we could do this, and we could add not Q, and that's nice. Now we have not P or not Q, but that's not the conclusion. Line 4 says at least one of not P or not Q is true. In other words, at least one of P or Q is false. But the conclusion says neither of them are true. So the conclusion says not what 4 says, but rather something stronger. So we're going to need to make an indirect assumption. So let's go ahead and do that. There's our indirect assumption. Oh, and actually, let me do that again. So, because this is a negation, you can choose either the unnegated form of it or the double negated form of it. And unless you have reason to, I mean, you can go back and forth between these with double negation, so there's no fundamentally wrong choice. This is just, but in general, choose the one without the negation because it will be quicker. Okay, so we do our show line, we make our assumption, and then we add our premises. Okay, then what? Well, now we want to look for elimination rule applications. So we have a disjunction on line 2, so that's where we're going to be doing elimination rules. The elimination rule for disjunction is MTP, so we want to do MTP if we can. What do we need for MTP? The negation of either disjunct. Well, hey, we have both the negations of both disjuncts, so we could do 2-3 MTP, or we could do 2-4 MTP. Let's do 2-3 MTP. Okay, we got Q, so now what should we do? Well, we could do 2-4 MTP, and now we have P. Now what should we do? We don't have our conclusion yet, but we have our new derivation method, and we can apply our new derivation method ID if we have a contradiction. And in fact, we do have 2 contradictions. In fact, we've done more than we needed to. We don't need line 6 because we have a contradiction on lines 4 and 5. We have Q, and then we have the negation of Q, so we have a sentence and its negation. So on lines 4 and 5, we have a contradiction, so we can say 4, 5, ID, and we're done. Q happens to show up inside of 1, but whatever. The point is, it doesn't matter. The point is that what we have on lines 4 and 5 is a contradiction, and that's enough. Okay, let's take a look at another example. So, and we'll say show conclusion. Here we're trying to show the negation of a conditional. It's not the case that if P then Q. And again, if we don't make an indirect assumption, we're getting nowhere. So we do need to make an assumption. And we can choose either one. Let's choose the unnegated one, or the undouble negated one, the one that is the unnegation of the conclusion. Now this is going to be straightforward. We have we actually can do two things with 2. We can do 2, 3 MP. We can also do 2, 4 MT. And again, we get lots of contradictions. In a direct derivation, if you were able to do modus tollens with, or modus ponens, say, with line 2, you wouldn't also be able to do modus tollens. But here, because of 3 and 4, you could do MP and MT. When you're in a situation where you can do MP and MT, you're going to get a contradiction. And again, you don't actually need to do both of them because we have a contradiction on lines 4 and 5. So 4, 5, ID. Good. Okay, we'll look at one more of these fairly basic ones, and then in the next video, we'll go on to look at some more complex problems. So show conclusion. We'll make an assumption. We can't make a conditional assumption, so we'll make an indirect assumption. P if and only if Q. Premise 1, premise 2. Okay, well, what should we do now? Well, we have elimination rules we can apply to line 2. We can use the BC rule, and that's really all we can do. So let's do BCL and BCR. Okay, are either of those useful? Yes. We can use lines 5 with 3 and 4. We can say if 3, 5 MP, that gives us Q. Shall we proceed? Let's check. Do we have a contradiction? We do. On lines 4 and 7, ID. So you have to ask yourself, do I have a contradiction? Do I have a contradiction? Do I have a contradiction? And then shows up, oh, good, I do have a contradiction. Okay, good. So that's all for this video. I will be doing some more examples in the next video.